Alright, this is going to be the video for the last progress check of the unit. So following along with the question, so we got, which of the following expressions can be differentiated using the product rule? So for A, we have arc sine of cosine of x. That would require the chain rule. So I would say that does not require the product rule. So for B then, for B we have sine of x and then arc cosine of x. Now notice here that that is a product right there. We're multiplying those functions together. So yeah, that would require the product rule. If I'm looking at C, no. If I'm looking at D, ha. Yeah, that's raised to the E. So for D, I see 12x squared plus 3e to the, or 3x minus 6 to the e power. This would require the chain rule, because I'd have to bring this down, subtract by 1, and then take the derivative of the inside. So this would be chain rule. So, but yeah, there you go. We already answered the question. So it's got to be B. So B. There you go. Okay, for the second question that we have here, we have which of the following requires the use of implicit differentiation. So, well, this one's really easy. I mean, I'm not even going to really talk about this one right here, right? Oh, wait a minute. Hold the phone. I spoke too soon. So, for A, you have 2y plus 3x squared minus x is equal to 5. For B, you have y is equal to e to the 3 plus x, and then plus x to the third. For C, you have y is equal to e to the y plus x to the third. And D, we got y is equal to x to the fourth plus 3 over 4x to the third minus 2. So which is going to require implicit differentiation? I was going to say A, but then I can also see C right here. So between these two, I can see that B and D are explicitly defined in terms of x, but A and C are not quite. But A would not need the implicit differentiation because I could solve for y easily. I can move these terms over, divide by 2, and I can explicitly solve for y in this case. And so it's got to be C, because I could not do that here where I have a y and a y here. So gotta go with C on that one. Alright, so next question. Let's see what we got. So for which of the following functions would the quotient rule be considered the best method for finding the derivative? So I don't really want to write these down. So for A, I'm looking at A and I'm thinking that's going to require that you could just use the chain rule there. For B, I wouldn't say for B. So if I'm looking at B, initially it might look like it because you have x to the cubed plus x divided by x. But then if you divide, that's equal to x to the third divided by x plus x divided by x. And that's going to be x squared plus 1. And so algebraic manipulation, I don't need to use the quotient rule. So not B. For C, that looks more like a chain rule. Now, I would say D is the answer if you're looking at that. D would need the quotient rule for sure. Can't do the same method like we did in B, so. Alright, let's check out the next one. So we have y is equal to 3e to the negative 2x. Find the third derivative. So y prime is going to be equal to negative 6e to the negative 2x. Y double prime is going to be equal to positive 12e to the negative 2x. And y triple prime is going to be equal to negative 24e to the negative 2x. And so that's got to be option A. Alright, and for the fifth one, so fifth one, we have a graph. The figure above shows the graph of f prime. The derivative of the function f, which of the four indicated values of x is f double prime least? Okay, so we're given the graph of f prime, and we're trying to see which of the points A, B, C, or D will f double prime be the least. And f double prime is going to be the slope of f prime. So if I'm looking at point A, f double prime is going to be 0, because the slope of f prime is 0 at that point. Okay, and then for B, that's definitely going to be negative. And for C, C is going to be negative 2, but it's going to be less negative than B. B has a steeper slope, and negative. So B and C are both negative, but B has a steeper slope. So B is going to be more negative than C, and D is positive. So it's not going to be D. So it's got to be B. So it's got to be B. For 6, this last one here. So let y equal f of x be a twice differentiable function. So we're given that f of negative 1 is equal to 5. We know that dy dx is equal to, we have 1/5. We have xy squared plus 4y squared. Find the second derivative. So dy dx at x equals negative 1. So let's find the second derivative, y double prime. So I'm going to start by doing the power rule. So that's going to be 2/5. We're going to keep the inside the same. Now we're going to multiply by the derivative of the inside. That's going to require the product rule. So it's going to be first times the derivative of the second plus the derivative of the first times by the second, then plus 4y prime. Okay, and then at negative 1, so these are important right here. This is all I need right here. At negative 1, y is going to be 5. So y double prime is going to be equal to 2/5. And then we're going to plug in negative 1 here, 5 here. So that becomes negative 25. So negative 25. And then if I plug in 5 here, that's going to be plus 20. Times by, so if x is negative 1, that becomes negative 2. So negative 2 times by 5 times by y prime. So we're going to have to plug in the point here too to find y prime, by the way. Times by y prime plus y squared. So that's going to be plus 25 plus 4y prime. Now, I guess before I continue, or I can keep going, y double prime is going to be equal to 2/5 times by negative 5 times by negative 10 y prime plus 25 plus 4y prime. So y double prime is going to be equal to negative 2 times by, negative 6y prime plus 25. So now I'm going to find y prime. So y prime is going to be equal to, so going up here, I'm going to plug in the same point here to find y prime. So it's going to be equal to 1/5 times by -1 right here, times by 5 squared, so -25. And then we're going to plug in, we have 4 times, so plus 20 squared. So this is going to be equal to 1/5 times by -5 squared. So that's going to be equal to 1/5 times by 25, which is going to be equal to 5. So then y double prime is going to be equal to -2, -6 times by 5 plus 25. So -2 times by -30 plus 25, which is going to be -2, times by -5. So that's going to be equal to 10. So D. Sweet. Okay. That one was fun. All right, and I think that finishes the progress check.